Math 1108, Section 8.2, continued, simplifying radical expressions. Uh, the next problem is to simplify the cubed root of y to the 20th. If exponents are multiples of 3, they are considered perfect cubes. So the largest factor of y to the 20th that is a perfect cube is y to the 18th. And y to the 18th times y to the 2nd is y to the 20th. So using the product property of radicals again, we'll rewrite this as the cubed root of y to the 18th times y to the 2nd. And then this is the cubed root of y to the 18th times the cubed root of y to the 2nd. And the cubed root of y to the 18th is y to the 6th, because 18 divided by 3 is 6. So y to the 6th multiplied by the cube root of y to the 2nd. Okay, the cube root of 81x to the 16th. The largest factor of 81 that's a perfect cube is 27. 27 times 3 is 81. The largest factor of x to the 16th that's a perfect cube is x to the 15th, because 15 is a multiple of 3. So we'll rewrite this as the cube root of 27 times x to the 15th times 3 times x. Then we'll apply the product property of radicals. This will be the cube root of 27x to the 15th multiplied by the cube root of 3x. And then we simplify the cube root of 27x to the 15th. The cube root of 27 is 3. The cube root of x to the 15th is x to the 5th, because 15 divided by 3 is 5. And then we multiply 3x to the 5th by the cube root of 3x. Okay, one more cube root. The cube root of negative 40y to the 38th. Negative 8 is a perfect cube, and negative 8 is a factor of negative 40. Y to the 36th is a perfect cube, and it's a factor of y to the 38th. So we'll rewrite this as the cube root of negative 8 y to the 36th times 5 times y to the 2nd. And then apply the product property of radicals again, and we get the cube root of negative 8 y to the 36th multiplied by the cube root of 5y to the 2nd. And the cube root of negative 8 is negative 2, so negative 2 is outside of the radical. And the cube root of y to the 36th is y to the 12th, because 36 divided by 3 is 12. And we multiply that by the cube root of 5y to the 2nd. Okay, we can apply the same concept to indexes of higher order. The 7th root of n to the 30th, well, if the exponent is a multiple of 7, it's considered a perfect 7th power. So the largest factor of n to the 30th that is a perfect 7th power is n to the 28th, because 28 is a multiple of 7. So we'll rewrite this using the product property of radicals as the 7th root of n to the 28th times n to the 2nd. And then this is the 7th root of n to the 28th times the 7th root of n to the 2nd. And then the 7th root of n to the 28th simplifies to n to the 4th, because 28 divided by 7 is 4. And then multiply n to the 4th times the cubed root. Sorry, not the cubed root, the 7th root. Sorry about that. 7th root of n to the 2nd. Okay, the fourth root of 32m to the 31st. The largest factor of 32 that's a perfect fourth power is 16. 2 to the fourth is 16. The largest fourth power factor of m to the 31st is m to the 28th. So we'll rewrite this as the fourth root of 16m to the 28th times 2m to the third. And then the fourth root of 16 is 2. The fourth root of m to the 28 is m to the 7th, because 28 divided by 4 is 7. And then we multiply that by the fourth root of 2m to the third. Okay, now we'll start talking about the quotient property of radicals. Okay, the quotient property of radicals. Let n be a positive integer. If the nth root of a and the nth root of b are real numbers and b is not equal to 0, then the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. Okay, so we'll apply that quotient property of radicals. We just start by writing, in this one, the square root. Remember, if the index is 2, it's a square root. So the square root of the fraction is equal to a fraction of square roots. So I'll write the square root of 32m to the 5th in the numerator. And then in the denominator, the square root of 81n to the 18th. And then we'll simplify the square root of the 32m to the 5th in the numerator and divide that by the simplified square root of 81n to the 18th. Okay, well, notice that the denominator simplifies nicely because 81 is a perfect square and n to the 18th is a perfect square. So we'll go ahead and simplify the denominator. The square root of 81 is 9 in the denominator, and the square root of n to the 18th is n to the 9th, because 18 divided by 2 is 9. And then the square root of 32m to the 5th, the largest factor of 16 that's a perfect square. The largest factor of 32 that's a perfect square is 16. The largest factor of m to the 5th that's a perfect square is m to the 4th. So this is the square root of 16 times m to the 4th times 2 times m. And then in the next step, we'll just simplify. The square root of 16 is 4. The square root of m to the 4th is m to the 2nd. And then we multiply that by the square root of 2m. Okay, that is the simplified answer. On the next one, we have the square root of 200x to the 8th divided by 289y to the 8th. So we'll apply the quotient property of radicals and write it as the square root of 200x to the 8th divided by the square root of 289y to the 8th. And the denominator simplifies nicely because 289 is a perfect square and so is y to the 8th. So the simplified denominator, the square root of 289 is 17. The square root of y to the 8th is y to the 4th. And then we simplify the square root of 200x to the 8th. Okay, well, the largest factor of 200 that's a perfect square is 100, and x to the 8th is a perfect square. So we can write this numerator as the square root of 100 x to the 8th times 2. And then in the next step, we'll just write the simplified result. In the numerator, the square root of 100 is 10, so 10 is outside of the square root. The square root of x to the 8th is x to the 4th. And then we multiply that by the square root of 2. And then the denominator has already been simplified. It's just 17y to the 4th. So this is the simplified quotient of the square root. Okay, next problem, the cubed root of 375 divided by 8. So we rewrite this as a quotient of cube roots, the cube root of 375 in the numerator, and the cube root of 8 in the denominator. In the numerator, the largest factor of 375 that's a perfect cube is 125. 125 times 3 is 375. And in the denominator, the cube root of 8 simplifies to 2. And so we'll go ahead and simplify the denominator. The cube root of 8 is 2. And then in the numerator, the cube root of 375 is the same as the cube root of 125 times 3. And in the next step, we'll just write the simplified result. The cube root of 125 is 5. We multiply that by the cube root of 3. And then the denominator is 2. So this is the simplified result. Then we have the cube root of negative 48 over 125. So we'll rewrite this as a quotient of cube roots, the cube root of negative 48 divided by the cube root of 125. The denominator simplifies to 5. 125 is a perfect cube, and the cube root of 125 is 5, because 5 to the 3rd power is 125. The largest factor of negative 48, that's a perfect cube, is 8, but we're going to factor negative 8 out and write it as the cube root of negative 8 times 6. Negative 8 times 6 is negative 48. And then in the next step, we'll just write down the simplified answer. The cube root of negative 8 is negative 2, and we multiply negative 2 times the cube root of 6, and this is all divided by 5. Okay, the next problem, the cube root of 64y to the 12th divided by 27x to the 6th. So this is the cube root of 64y to the 12th divided by the cube root of 27x to the 6th. Now this one's going to turn out to be pretty nice because 64 is a perfect cube. 4 to the 3rd is 64. Y to the 12th is a perfect cube because 12 is a multiple of 3. And also in the denominator, 27 is a perfect cube, and x to the 6th is a perfect cube. So we can just write down the simplified end result. The cube root of 64 is 4. The cube root of y to the 12th is y to the 4th, because 12 divided by 3 is 4. In the denominator, the cube root of 27 is 3, and the cube root of x to the 6th is x to the 2nd, because 6 divided by 3 is 2. Okay, then one more. For this one, the 4th root of 32a to the 18th over 625b to the 12th. So this is the 4th root of 32a to the 18th over the 4th root of 625b to the 12th. In the denominator, 625 is a perfect 4th power. 5 to the 4th is 625. b to the 12th is a perfect 4th power also. 12 divided by 3 is b to the 3rd. And so we'll just write the denominator in simplified form. The 4th root of 625 is 5. The 4th root of b to the 12th is b to the 3rd. And then to simplify the numerator, the largest factor of 32, that's a perfect 4th power, is 16. The largest factor of a to the 18th, that's a perfect 4th power, is a to the 16th. And then multiply that by 2a to the 2nd. And then That will simplify. I'm running out of video time, so I'll leave the rest of that for you to do.